This small device controls your comfort, your energy bills, and quietly decides how hard your home works every single day. Yet most people don't really understand it. Today, we're breaking down everything you need to know about a thermostat. What it is, how it works, why turning it up doesn't heat faster, and how this tiny box can either save you money or drain it without you noticing. And stay until the end, because the future of thermostats is changing faster than your home ever has. Let's begin. A thermostat is the brain of your heating and cooling system. It doesn't create heat. It doesn't create cold. It simply tells your HVAC system when to turn on and when to turn off. For those who don't know what HVAC means, it stands for heating, ventilation, and air conditioning. A thermostat exists for two reasons: comfort, by keeping your space at the temperature you want, and energy efficiency, by avoiding unnecessary heating or cooling. The common misconception most people have is that turning the thermostat higher does not heat your home faster. It only tells the system to run longer. That misunderstanding alone costs people a surprising amount of money. Thermostats didn't start as smart devices. Early thermostats were purely mechanical, no electricity, no screens. They relied on bimetallic strips, metals that bend when heated. Later came mercury switches, which improved accuracy but raised safety concerns. Then digital thermostats arrived, precise, programmable, and predictable. So why did smart thermostats exist at all? Because people didn't want to think about temperature anymore. They wanted it handled automatically. Here's the core logic. The thermostat constantly compares set point temperature, what you want, and actual room temperature, what it senses. When the difference crosses a threshold, it sends a signal. Either heat on, cool on, or system off. This on-off logic uses something called hysteresis, which prevents rapid cycling. And again, turning it way up doesn't make heat arrive faster. It just delays when the system turns off. Let's break down the types of thermostat. Firstly, mechanical thermostats. They use physical movement. They are simple and durable. They are less accurate. They are still used in older buildings and industrial spaces. Secondly, digital thermostats. They use sensors and microcontrollers. They have more precise readings. They have better temperature stability. Then we have programmable thermostats. They follow schedules. They reduce heating and cooling when you're away. It was one of the first real energy-saving upgrades. Lastly, we have smart thermostats. They use Wi-Fi. They can be controlled using an app. They learn your habits. They integrate with smart homes. But here's the truth: a smart thermostat isn't efficient by default. It's only as smart as how well it's set up. At first glance, a thermostat looks simple. But inside, it's a carefully balanced system where every part has a job. Let's break it down. 1. Temperature sensor. This is the thermostat's sense of touch. It constantly measures the temperature of the surrounding air using thermistors, digital temperature sensors, or older mechanical elements in legacy systems. If this sensor is inaccurate, everything downstream is wrong. The thermostat doesn't know it's wrong, it just makes bad decisions confidently. 2. Control circuitry, the brain. This is where thinking happens. The control board compares actual temperature to the set point. It applies logic rules, on-off thresholds, delays, schedules. It also prevents rapid cycling that can damage HVAC equipment. In smart thermostats, this is also where learning algorithms run, occupancy patterns are analyzed, and weather data is factored in. 3. Relays and switches. Relays are the muscle. They physically open or close electrical circuits that signal heat on, cooling on, fan on, auxiliary heat. When you hear a click inside a thermostat, that's a relay doing real work. 4. Display and user interface. This is how you communicate with the system. Buttons, dials, touchscreens, apps, they don't control HVAC directly. They simply pass your intent to the control circuitry. Bad interfaces lead to bad settings, and bad settings waste energy. 5. Power source. Thermostats are powered in two main ways: batteries and C-wire that is required for smart features. Here's the key idea. A thermostat does not send temperature. It sends commands. Most thermostats use 24-volt control signals. The HVAC system does the heavy lifting, the thermostat just gives permission. A compatible thermostat knows when to start gently, ramp up, back off early. Incompatible ones don't, and efficiency suffers silently. A thermostat must match HVAC type, voltage requirements, number of stages, heating method. Thermostats save energy by avoiding unnecessary temperature swings, by reducing runtime when spaces are unoccupied, by preventing short cycling. They waste energy when poorly programmed, when constantly adjusted manually, when installed in bad locations. If this is helping you understand your home better, like the video and subscribe. It helps more people avoid expensive mistakes. Placement is critical. A thermostat should be about 1.5 meters off the floor, away from doors and windows, far from heat sources, in a representative room. Bad placement means bad data, and bad data means wasted energy. Now we reach the turning point. The future isn't just smart screens. It's AI-driven climate prediction, smart grid integration, sustainability-focused optimization, fully automated comfort systems. Thermostats won't just respond. They'll anticipate. That small device on your wall isn't just a thermostat. It's a gatekeeper between comfort and discomfort, between efficiency and waste, between control and automation. And as homes become smarter, understanding when to take control becomes more important than ever. Your thermostat is evolving from a switch to a decision maker, to a system that acts before you ask. And in a world where homes think for themselves, knowing how to take control when automation fails may be the most important skill of all. That's exactly why you should watch this next video that is about smart home fail-safes and manual overrides, so you're never locked out of your own comfort. Thank you for watching and see you in the next video.